So, with the advent of generative AI and artificial intelligence in particular, there is a lot of confusion regarding why exactly do we need GPUs for training our machine learning pipelines or to even train our generative AI model of our own. Let's say you want to fine tune a particular instance of a GPT engine, then people say you need a GPU for that particular functionality. Now, a lot of confusion is there. A lot of people don't know why exactly do we need GPU, or can we achieve the same functionality of fine tuning a model with CPU? uh, the simple answer is no, you cannot achieve that functionality of fine tuning your GPT engine with CPU. You would require a GPU in particular. So if you want to train your generative AI model on, or if you want to add a few extra layers of information of your own data set, that which is exactly what happens in fine tuning your GPT engine, we need GPU instances for that particular circumstance. So this video is aimed at explaining you the major differences between GPU and CPU, uh, and hence you would know why NVIDIA, due to its GPU offering, is on the boom right now. Uh, so yeah, in this video we're gonna discuss what exactly are the major differences between GPU, CPU, and uh, I'll give you some bonus information on how Microsoft in the back end is using the GPT engines of OpenAI and keeping uh, track of them using some GPUs from NVIDIA, and how Microsoft lets you train your or fine tune your own GPT engine, add custom layers of your dataset on top of your GPT engine with the help of these GPUs at the back end. So, coming to the first question, what exactly is the difference between a GPU and CPU? What are the performance metrics of these GPU and CPU? So, let me make you understand with this with the help of a simple mathematical analogy. So, for all the engineers out there, let's say you have an integral, which is I naught. Okay, so this is the main integral. Now, this integral is a combination of sub-integrals I1, I2, and I3. So I naught is your main integral. I1 is one sub-integral of this I naught, which is the main integral. I2 is the second sub-integral, and I3 is the third sub-integral. So, in a very common sense way, in a very common sense manner, to compute the total value of I naught, what you need to do is you need to compute the value of I1, then I2, then I3, and sum all of these values of I1, I2, and I3 respectively. And when you sum these values, what you have is the total value of I naught. Now, let's say I am an engineer and I want to perform this particular calculation with the help of a CPU. Now, if I go with the help of CPU, what the CPU is going to do is CPU performs calculation in a sequential manner. All right. So what I mean by sequential manner is CPU would first of all compute the value of I1, then it would compute the value of I2. Then after computing the value of I2, it would compute the value of I3. And after it has computed firstly the value of I1, secondly the value of I2, thirdly the value of I3, it is going to add all of these values and then give you the value of I0. So let's say if computing the value of, on a very average scale, let's say computing the value of I1 took you 3 seconds. Similarly, computing the value of I2 took you 3 seconds again. And computing the value of I3 took you 3 seconds again. And let's say the addition of all of these I1, I2, and I3 was somewhat approximately equal to 0 seconds. So the total time that the CPU takes to compute the value of I0 is equal to 3 plus 3 plus 3, which comes out to be 9 seconds. So with using CPU, what you're going to do is you are getting the value of, or you are computing the value of I0 in a time frame of 9 seconds. Now let's see what would have happened if we had used a GPU instead of a CPU to compute all of these values of I0. So I'm writing the integral again. I0 is equal to I1 plus I2 plus I3. So GPU performs calculations in a parallel manner. Parallel manner. So what I mean by parallel manner is GPU would not take the sequential route. just as the way the CPU was taking. So while the GPU is computing the value of I1, at the same time it's going to compute the value of I2, and at the same time it's going to compute the value of I3 as well. So let's say if computing the value of I1 on an average took 3 seconds, I2 again took 3 seconds, and I3 again takes 3 seconds. So now the total time frame, the total time period to compute the value of I naught would come out to be 3 seconds only. Now this is a major reduction in time. 3 seconds is because when it's computing the value of I1, at the same time it's computing the value of I2, and at the same time it's computing the value of I3. So because CPU took, I mean, the calculation where CPU took 9 seconds, GPU at that particular calculation takes only and only 3 seconds, just one third of the time. Now, at this small scale, it would come to you as a very minimal reduction in time. But when you're talking about thousands of billions of parameters, uh, this major reduction in time comes in very handy. So let's say if you're doing a calculation with a CPU, if that calculation which is done by CPU takes you 10 days, with GPU it can take you even an hour, or with a combination of GPUs it can take you even an hour, or let's say in a couple of minutes as well. So this uh, reduction in computational time is of very high importance here. Now, let us understand how Microsoft enables you to fine tune your GPT engine. Fine tuning is essentially adding layers of your own data on top of that GPT engine, so that the GPT engine takes into account your data and answers questions according to them as well. So, let's see how Microsoft enables you to fine tune your own GPT engines. So, in the backend, in the Microsoft infrastructure, what happens is you have a cluster of GPU. So let's say you have GPU 1, which is with the symbol of G1. Then again, you have GPU 2, G2, and similarly, you have N GPUs uh, with a symbol of Gn. Now, these GPUs are interconnected. So these GPUs can exchange information between them. G1 can exchange information with G2, similarly G2 with G3, and Gn minus 1th GPU can exchange information with the Gnth GPU. Uh, Now, on top of these GPUs, you have something which is called as hypervisor to stimulate or orchestrate the performance or the working of all of these N GPUs that you have here. On top of that hypervisor, you have something called as a machine learning framework. Let's take the example of a very popular machine learning framework, which is known as the deep speed framework. So, in a nutshell, what this machine learning framework does is it orchestrates uh, the purpose, the workflow of training your machine learning pipelines uh, into these GPUs. So, the deep speed machine learning framework would orchestrate the process of parallel execution of your machine learning pipeline in these GPUs. So, it would uh, give separate work to the GPU 1, the GPU 2, and the nth GPU. And at the end, it would let GPU 1 exchange information with GPU 2, and then similarly let the n minus 1th GPU exchange information with the nth GPU, and so on and so forth, thus completing your machine learning framework. So this is how the infrastructure, the architecture of uh, the Microsoft backbone looks like, which enables you to uh, to fine tune your own GPT engine. So this was pretty much it for this video. I hope I made you uh, fetch some knowledgeable insights into what exactly are GPUs, what exactly are CPUs, and a bonus information on how uh, th- th- uh, the Microsoft architecture is based in the backend, which lets you fine tune your own uh, GPT engines. Pretty much it for this video. Please like, subscribe, and stay tuned to this channel for more updates and interesting videos like this. Have a nice day ahead.